Okay, here's an example. We'll do a couple of examples today. So suppose somehow we called up Toyota and found out that Toyota Corollas have an average gas mileage of 34 miles per gallon and a standard deviation of 2.6 miles per gallon. We want to make predictions about a fleet of 50 cars. We're not going to make predictions about individual cars, but about a whole collection of cars. Okay, first thing we're going to do every single time is identify our variable. Writing down this line right here is a required step. If you don't write this down, you lose points. Let mu represent or be the mean gas mileage of Corollas. That's the thing we're trying to study. With proportion problems, our main variable is little p. With mean problems, it's mu. So it's the first thing we write down. Let mu be whatever it is we're trying to study. We're told that mu is 34, sigma is 2.6, and then we do samples of size 50. Now we're supposed to check all those conditions. I'm not going to bother checking the conditions here, but if you check them, as long as we do a good sample here, as long as this fleet of 50 cars looks like the whole population, then as long as we meet those conditions, all possible samples of size 50 have averages that follow a normal distribution. And the average of all sample averages is 34. And the standard deviation is sigma divided by square root of n. We get this tiny little number here. We want to know what's the probability that this bunch of cars sitting on a parking lot right now, this fleet of 50 cars, gets an average of 35 miles per gallon or more. So same steps we always did. Draw the picture, find z-score, normal, CDF. It's always the same steps. Right in the middle was mu. Evidently, I couldn't make the picture have the little symbol mu there, so I just gave up on it and typed it. that should be that little guy right there. Mu equals 34. I want my sample average to be 35 or above. Okay, we got a brand new formula for z-score. Remember, this semester, we're going to have like 8 different formulas for z-score. Our new formula is x bar minus mu over SD. This is where mistakes happen on these problems. In this problem, I've got 2 different standard deviations floating around. The one for the population and the one for the sample distribution. Mistakes happen because people go back and use this one. That is the wrong standard deviation. We want the standard deviation we just calculated, the one that's over root n. So the one we want minus the one in the middle over that standard deviation we literally just calculated. And we get this z-score, 2.72. Throw it into normal CDF. Smallest thing I shaded to biggest. I shaded up to infinity. And now our sentence, we're not making predictions about individuals. We're making predictions about the average of a sample. So it's not the probability that one car gets 35 miles per gallon. Oh, a whole bunch of cars get 35 miles per gallon. It's that if you grab 50 of them, what's the probability the average of all 50 of them is going to be 35? That's what we're finding. And here, it would be that tiny number. The probability that the mean gas mileage of these 50, of the sample, if you don't mention the sample in your sentence, you've done something wrong. We're always making predictions about samples.